Hi, welcome to the Wilmer Lab. We are a small team of engineers led by Dr. Chris Wilmer, who research a wide variety of computational topics. But our primary focus is on the design, discovery, and analysis of a special class of crystalline materials known as metal organic frameworks, or MOFs. We study these MOFs for a wide range of applications, such as gas storage, chemical sensing, use as electrodes, and more. And the way that we do this is to use various computational techniques such as molecular dynamics simulations, density functional theory, and Monte Carlo simulations. We also use a huge variety of in-house software. But in addition to our research, the Wilmer Lab prides itself on its entrepreneurial focus, with numerous members of the Wilmer Lab, past and present, having started their own companies such as Numet Technologies, Aeronix, and Paw Print Oxygens. We also frequently compete and succeed in business plan competitions offered at both the University of Pittsburgh and beyond. But let's take a quick look at some of the projects that we've been working on. First, we have algorithmic materials design. And what we wanted to do was take a library of existing structures and predict new ones. And so the way that we did this was to look at these existing structures and break them down into key building blocks. And then by disconnecting and reconnecting these building blocks in a way that you would Legos or Connects, we can design materials that have never before been discovered. Using the same thought process, we wanted to see if we could actually predict the fundamental limits of all materials. And so the way that we've done this is to fill a simulation box with atoms at random. And then, using the same techniques that we would use to analyze real materials, we analyze these pseudo-materials. And then, by continuously and intelligently updating the way that these atoms are arranged in the box, we can actually discover fundamental limits that have never before been known, such as how much gas can any material ever absorb, or how fast can heat transfer in the most perfect material. Another project that we're very proud of is our design of a chemical gas sensor array, often called an electronic nose. And the goal here was to see if we could design the perfect chemical sensor which could rival a dog's nose, or even better, beat a dog's nose at detecting gases. And so what we've envisioned is a small handheld sensor device filled with electronic sensing chips. And on each of these chips, or sensor arrays, we have a nanoporous material, those being the MOFs. MOFs actually have really impressive and diverse gas absorption properties, and so by combining them in just the right way, we can create a sensor array that's able to detect a huge variety of gases super accurately and super quickly in a way that no other technology has ever done before. We do more than just that. We've done research on building and racing nanocars computationally, on the thermal conductivity of MOFs and other solid materials. We've tried to reimagine and reutilize blockchain technologies for a number of interesting problems, and really anything MOF related that you can imagine. We strongly encourage you to check out our website if you're interested, or reach out to any of us with more questions. You can email any one of us below or any of the grad students not listed here. Thanks.